Hi, this is Riddhi and this is my video assignment.
Okay, so the question is we have been given this equation z is equal to 1000 minus 0.005 x square minus 0.01 y square, and this is the point. So the first part of the question is if you walk due south, will the person ascend or descend? Okay, so before starting, first we have to calculate the partial derivatives of z. So delta z upon del x is equal to, we have to differentiate it with respect to so it will come out to be minus 0.01 x, and del z upon del y will be equal to minus 0.02 y. Now starting the first part, so for that first we'll calculate the position vector. So as we know that the person is going towards south, so this is plus j, and this is minus j, and this is plus I. So south is minus j, so the position vector will be v is equal to 0 I minus j, because there is no movement in this direction or this, the person is just going in the south direction. Now we'll calculate the unit vector, which will be calculated by this formula, vector upon magnitude of v. So minus j upon 1, which is equal to minus j. So for calculating the rate, we have to calculate the directional derivative. So du fxy, which is also equal to delta fxy dot u. Now this delta fxy is also called the gradient vector, which is the matrix of all the partial derivatives of partial derivatives of the given function, del f upon del y, and so on. So for this, we already know the values of del z upon x and del z upon y. So that is minus 0.01 xi cap minus 0.02 yj cap dot minus j, because u vector is minus j. So now we'll put the values. Now it will come out to be as 0.02 y. Now we know from the points that the value of the value of y is 40, so we'll put it in this, so it will come out to be 0.8. Now since the rate is positive, that means that the person is ascending. If the rate would have been negative, that would have meant that the person is ascending. Now for the second part, the second part is that if you walk due northwest, will the person ascend or descend? So similarly we'll calculate the position vector this time as well, which will come out to be as minus I cap plus j cap. We'll calculate the unit vector also in the similar way. And it will come out to be 1 by root 2 minus I cap plus j cap. I've just taken the position vector and divided it with its magnitude, which will come out to be as root 2. Then in the same way we'll again calculate the directional derivative like we did in the next previous step. Dot u. So minus 0.01 x I cap minus 0.02 y j cap, and the dot product with 1 upon root 2 minus I plus j. So it will come out to be as minus 0.1 x upon root 2 and minus 0.02y upon root 2. By putting the values of x and y from a point which is p is equal to 60, 40, 966, that is x is equal to 60 and y is equal to 40, we'll put the values and the resultant value will be minus 0.2 upon root 2. Now since the rate, this is our rate, is negative, so the person will descend. Now moving on to the third part, which is we have to calculate the rate and the angle. So first we'll calculate the rate. So we already know our gradient vector is minus 0.1 x minus 0.02 y. We'll put the values in it and it will come out to be as I cap and j cap as well. So it will come out to be as minus 0.6 I cap minus 0.8 j cap. Now to calculate the rate, we have to take the magnitude of this. So the magnitude of gradient vector 0.6 square plus 0.8 square, and it will come out to be as under root 1, which is 1. So this is our rate. Now calculating the angle, we already know that dy by dx, which is also a rate and which is also equal to magnitude of gradient vector, is equal to tan theta. We know that, and we have calculated we have just now calculated that the rate our rate, which is 1, so that means 1 is equal to tan theta, and then theta will be equal to 45 degree.